This is a Chebyshev's problem, and even though we have it in our notes, this one's been a little bit tricky. So I wanted to go ahead and do one in ALEKS to help a few students out. Okay, we have a nationwide test taken by high school sophomores and juniors, has 3 sections, each scored on a scale of 20 to 80. In a recent year, the national mean score for the writing section was 51.0 with a standard deviation of 11.0. Based on this information, complete the following. So let's write down what we have so far. So we know that the mean, and I'm going to assume that this is a population since they said national. We know that the mean is 51 and the standard deviation is 11. In the first problem we're asked, or the question is, according to Chebyshev's theorem, at least blank % of the scores lie between 34.5 and 67.5. So 34.5 and 67.5 are actual scores on this 20 to 80 scale. And what we're trying to say is what percentage? Is it 50%? Is it 75%? Something like that. Well, recall our Chebyshev's formula is 1 minus 1 over k squared. Well, k is the number of standard deviations away from the mean. And in the Chebyshev's formula, it has to be greater than 1. So if it's just 1, it doesn't work for Chebyshev's. Okay, so our job in part A is to first find how far away the values are from the mean. So for those of us that are a little more visual, this is kind of what's going on. We have get all my tools here. Okay, so we have our data. However it's shaped. Remember, Chebyshev is a little more loose. It doesn't have to be bell-shaped. It could be skewed or kind of have a different shape. Let's just say it looks like that. And if our mean is here, and our mean of 51, and what they're asking us is between 34.5, so somewhere over here, and 67.5, so somewhere over here. Between those two values, how much of our total value is captured in between those values? That's what's being asked. So first we're going to find this distance here. Well, 61.5 minus 51 is 16.5. Now that's the raw difference between the mean and this upper score. But what I'm really interested in is how many standard deviations that is. So to find the number of standard deviations, divide by the given standard deviation. So I'm going to take the 16.5 and divide by 11, which they told us was the national standard deviation, and that gives us 1.5. So that means this distance here is 1.5 standard deviations away. So 1 standard deviation away is 11, which would take us up to 62. But if I take half of the standard deviation, that puts me up with 67.5. Now you could do the same thing for 34.5. Subtract it from the mean, divide by a standard deviation. But you're going to find that's the exact same value. Usually what they're giving you is a symmetric interval. So you can do it to prove it to yourself, but you don't necessarily need to. Okay, next, I'm going to take this 1.5, which is my K, and plug that into Chebyshev's. So plug K into Chebyshev's formula. Okay, so remember that's the 1 minus 1 over K squared, and we found K to be 1.5, so 1.5 squared, and that comes out to 0.555. You get a bunch of repeating 5s. So we can round that to 56%, which is the first choice in our little drop-down menu. Okay, so taking a look at B, pretty much the same thing. We're going to do it the same way. Maybe we can go a little bit faster this time. So part B, first I'm going to decide how far away am I from the mean in terms of standard deviation. So the upper limit, and it doesn't matter which one you do, the lower or the upper, but I'll say 73 minus 51 is 22. And then 22 divided by the number of standard deviations is just 2. So K is 2. So 73 is 2 standard deviations away. One group of 11 and then a second group of 11 away from the mean 51. So now I plug the K equals 2 into Chebyshev's. So that's 1 minus 1 over 2 squared, which is 1 minus 1/4, or 3/4, which is 75%. And there it is on our drop-down menu. Okay, so that takes care of how to use the Chebyshev's theorem, at least on A and B. So you're figuring out how far away you are from the mean in terms of standard deviation. You should get a pretty low number, like 1.5 or 1.25 or 2.1 or something like that. Then you take that number, plug it into Chebyshev's, and you should get a percentage that's on that drop-down menu. For part C, suppose the distribution is bell-shaped. According to the empirical rule, approximately blank of the scores lie between 29 and 73. Same thing, we need to find how far away we are in terms of standard deviation, and then we can consult our general percentages for bell-shaped data. So this is part C. So 73 minus 51, well, we already did that. We know that that's 2 standard deviations. And if you remember, with the empirical rule, that means that's going to be, the empirical rule says, I should say, says about 95% of the data is contained within 2 standard deviations of the mean. And again, if you check the lower number, it would also be 2 standard deviations away. So if we look here at our little drop-down menu, there's 95. And that works. Okay. Let's take a look at the very last one. Part D. Suppose that the distribution is bell-shaped. According to the empirical rule, approximately 68% of the scores lie between blank and blank. Well, here we're just working backwards. So we know how much of the data is contained within 2 values. We just need to know what those 2 values are. Okay, so remember or recall, the empirical rule states that approximately 68% of the data is within 1 standard deviation of the mean. So we know it's 68%. That means I just need to find values that are 1 standard deviation above the mean and 1 standard deviation below the mean. So we know that the mean is 51, and we were told that the standard deviation is 11. So to go above it, I'm going to take the mean and add on 11. So that gives me 62. And then to go below the mean, I'll take the 51 and subtract off 11, and that gives me 40. So again, if we're a little bit visual, what's happening is we have our bell-shaped data. Here's our mean in the middle, 51. We know that what's ever contained in here, we know that that's 68%. But according to the empirical rule, that means I go 1 standard deviation this way and 1 standard deviation, let me say 1 standard deviation instead of sigma. I think that'll make more sense. Okay. So 1 standard deviation above and 1 standard deviation below. Well, we're told the standard deviation is 11, so this has to be 62. And this has to be 40. So the values I type in would be 40 and 62. Okay, so hopefully that will help a few of you that got a little bit stuck on Chebyshev's, and you can keep moving through.